Hello. In the next series of activities, we're going to be using a hand crank generator. So let's have a closer look at our hand crank generator. You can see here that we have our handle, our crank. You can see as well we have some cogs inside here, and they are gears linked to the drive shaft. And then you have this component here, which you might recognize as a motor. Now normally a motor has an electrical supply to it that causes the spindle to turn, and that might drive a fan or a propeller. But what happens when we turn this handle and drive the spindle manually is that the motor actually creates an output, and that means that then it becomes a generator. You can see here that we have a lead running out of the back of our hand crank generator, and that then comes into a red plug lead and a black plug lead. There's a label on our hand crank generator that shows us which way to turn to get a positive red and a black negative. So that means that by turning the crank handle in one particular way, we get a polarity that is the same as conventional current, going from the positive through to the negative terminal. But if we turn the crank handle anti-clockwise, we'll get a negative current. So that goes against the conventional current flow, which means that it goes black positive and red negative. We can show the output of our hand crank generator using a multimeter, and we're going to show it in voltage. So we're going to use our multimeter as a voltmeter. Here's our multimeter. You can see we have a volts DC scale here, and we're going to use the 20 volt setting. We have 3 sockets. One is marked COM. We always put a lead into COM. And the other one we're going to use is marked volts, ohms and milliamps here. So we're going to do a little experiment where we're going to look at the direction of the way that we turn the crank handle, and also the rate and how that affects the output. So I'm going to plug one lead into our multimeter, once I've made sure that our leads are fully untangled. When this is supplied, the leads are nicely tied up. You must make sure that when you use this, you unwrap the lead. So now I'm going to connect the black lead or black plug into the COM socket and the red plug into the volts, ohms and milliamp socket. I'm going to turn the multimeter to 20 volts DC, and now I'm going to turn the crank handle clockwise, and we're going to do 1 revolution per second. So 1, 2, 3, 4, 5, 6. And you can see that I have an output of around 3.5 volts. Now if I increase the rate which I turn the crank handle, you should be able to see that I have an output of around 6 volts. So by increasing the rate in which we turn our crank handle, we've increased the output. Now, if I turn our crank handle in the anti-clockwise direction, first of all, at the 1, 2, 3, you see again that we're getting an output of around 3.5 volts, but this time we're getting a negative output. So we're getting an output of around negative 3.5 volts. Again, if I increase the rate, now we're getting around 6, but it's negative. So the output of our crank handle, turning it in an anti-clockwise direction, has become a negative output. So we've been able to show that our motor is now a generator because we're manually turning the spindle. We're getting an output, and depending on the rate at which we turn the crank handle, we get an increased higher output. As long as we turn it in a clockwise direction, we get a positive electrical output.